Hello everybody, CF Maths here, coming to you with another GCSE difficult question. So today we're looking at circle theorems, and this is the question we've got. Just before I get into the video, just want to say that I don't look at these questions beforehand, so I'm seeing them completely for the first time. This will hopefully give you an insight into my thinking and sort of the approaches you need to take when you are looking at these questions yourself. So let's look at the problem. We've got C, D and E are points on a circle centre. The origin, AEB is a tangent to the circle at E. CD equals DE. That's the first key bit of information. And the second is angle AEC equals X. So let's just figure out what these mean. So this one here, CD equals DE. So before I've even looked at what the question's asking, this tells me that triangle CDE is isosceles. Okay, and that I feel is going to be important at some point. The next one, angle AEC equals X. Well, AEC is going to be this angle here. Okay, so just rub that out. We're looking, or we've got that this angle is X degrees. Okay, so where do we go from this? Find the size of angle OED in terms of X. Give reasons for your working. So OED is going to be this angle here. Okay, that's the angle we are looking for. So what do we know here that can help us? Well, I can think of two circle theorems that are going to help us here. Firstly, because the question mentions tangent, we're going to use the fact that a tangent meets a radius at a right angle. Okay, so tangent meets radius at right angle. So in other words, this implies that angle OEB is 90. Okay, so angle OEB is this whole angle here. If I just choose a different colour. So this is angle OEB. All right, how else can we go about this question? So let's have a look. So the angle we know that it is X tells us that also this angle here is X. Okay. Now, if you want to pause the video and have a think about why that's true, then feel free to. And if you've done that, then let's figure out why. Well, we've got a theorem called the alternate segment theorem. So the alternate segment theorem says if we know that this angle here, or if we know what it is, that is the same as the opposite angle in the triangle. Okay, I have proved all the circle theorems on my channel before, so feel free to go back and find that. So just to add the reasoning in for that, so what I'm going to say is angle AEC is equal to angle CDE by the alternate segment theorem. Brilliant. So now what we can do, we know the top angle in the isosceles triangle is X, and we also know that the two base angles in an isosceles have to equal the same. So in other words, each of these two angles here that I'm going to draw in, so this one and this whole part here, okay, have to be the same, and they are both going to be equal to 180 minus X divided by 2. So I'm going to write that bit of reasoning down. So angle DEC equals 180 minus X over 2 as base angles in an isosceles are equal. Brilliant. So we're almost there now. We know this whole angle here. Okay. And we want to know the bit in blue, okay? So, where can we go from this? Okay, so we also know that angle OEB is a right angle. So, the part I've got in red here. So we also know that this is 90 degrees. Okay, so if we could somehow work out, I just make a small erase, if we could somehow work out this one, then we could do 90 degrees, subtract the one in red. So how can we do that? Well, we've used the alternate segment theorem before. Let's use it once again. So whatever this angle is here has to be the same as this one. So in other words, if this one we've already worked out as 180 minus x over 2, then this one here also has to be 180 minus x over 2. So now what we need to do is do 90 subtract that. So we've got 90 subtract 180 minus x over 2. Let's convert 90 to 180 over 2. And now what we see is, if I put this in brackets, we get 180 over 2 minus 180 over 2 plus x over 2, because we've got a negative and a negative. So clearly these are going to cancel, and what we are left with is x over 2. Really hope this helps. So it's combining a few circle theorems together. If you did enjoy, please leave a like. Have a great day.